Well, it's my pleasure today to introduce Dr. Wallace Green. Wallace is the Director of Diagnostic Virology at the Penn State Health Hershey Medical Center. In 2017, Wallace visited the adult issues class to discuss the risk of a global viral pandemic. And now, just over 3 years later, the world has experienced the most devastating pandemic in over 100 years, with more than 140 million cases worldwide and over 3 million deaths. So what have we learned from this experience? How has it changed our ability to respond to the risk of global pandemics in the future? And what should we be doing now to prepare for the next pandemic? Now, these are just a few of the topics we'll be addressing over the next hour as we discuss COVID-19 lessons learned. So Wallace, good morning and welcome back to Derry. It's good to have you here.
Oh, it's great to be here. I am still working on getting my talk up. I should have been practicing this when I first got here instead of visiting.
All right, I think
did that appear?
We're seeing your screen, yes.
Okay, so if I do this.
Looks good.
Yeah. We're all good? Great. Okay, well, good morning, all. It's a beautiful day to be out. I'll start off with a little fact here that's very seasonal. I just read this morning that thanks to everybody masking up, the visit to allergy clinics are way down this spring. So there's another reason to wear your mask. Apparently it works great on this pollen that we're seeing now too. Okay, what I'm going to do this morning is I'm going to go with some just basic facts with what we have learned about the coronavirus. And that's important, particularly when we get to the vaccine, so everybody can understand what is going on with them. There is a tremendous amount of misinformation leading to a lot of misunderstanding, leading to people not getting vaccinated. And so I want to share enough information so hopefully everybody can go out and help with this problem we have of people not getting vaccinated because they have read or been told some stuff that's just not right. I direct the Diagnostic Virology lab here. Thanks to this pandemic, around the first of the year, we added a second lab. That is a COVID-only lab. It's for fairly high volume. We have 3 new platforms in there for testing, and I've more than doubled my staff. So that's what this pandemic has done for us. It's, well, I don't want to get too far ahead or oh. There we go. Okay. So a little bit. I'm going to use COVID-19. You'll hear a lot in that's the name of the disease. It's COVID-19. This is not the 19th coronavirus, as some may have heard. This is the year that it was first recognized. A few weeks later, we'd be talking about COVID-20, but that's how we got COVID-19. That's the year it was described. The virus itself is SARS. And the COVID-2, SARS-1, of course, was the one, the pandemic we had a number of years ago. And that one was very short-lived compared to this one. And the reason is that you are not contagious unless you were ill. So it was very easy to identify the people who need to be in quarantine, put them in there. And that was that outbreak. It wasn't even an epidemic. That outbreak got snuffed out pretty quickly, and we have not seen another one since. Of course, the problem with COVID-19 is half the people who are highly infectious have no symptoms. And we're even seeing now that after you are fully vaccinated, you may be reinfected, again, no symptoms, but could still shed the virus. So that's why the best way, I think the only way we're going to get out of this pandemic is to vaccinate enough people. Now, what I said about being infectious after your vaccination and you're immune, that's rare. It does not happen all the time. Usually you will not become reinfected, but it can happen. And that's the main reason, after we're all masked up and everything, we still need to, after we're all vaccinated, we still need to wear a mask, particularly if you're in the presence of people who have not been vaccinated or at high risk. Okay, so there was a question about pandemic. How's this coronavirus, this COVID-19 different from previous pandemics? Now, the previous pandemic we had was in 2009, when we had the swine flu come up out of Mexico. And that one exploded really fast. Influenza is a very contagious, for the most part, virus. I first heard about that virus when I was at a meeting down in, I think it was in Daytona in May. By June, we had a full-blown epidemic and pandemic by a few weeks after that. That ripped around the world much, much faster than coronavirus did. But again, it died off much quicker because you didn't have people super contagious with no symptoms running around. Okay, so coronavirus itself, there are a lot of different coronaviruses. We have been identifying 4 different coronaviruses in my lab for years now, and they are pretty much the coronaviruses that will cause a cold. You may swear you had the flu. Some of my techs have had it in the past, but when we tested them, we found out they had one of these coronaviruses, and yeah, your vaccine's working, but you've got this and go home. But that's usually the extent of it. It's just, you know, a bad cold in the wintertime. There are a few instances where these viruses have jumped to humans and caused severe disease. Of course, we just mentioned SARS. That came from people, thought to be from people in China eating these Cheviot's cats. I'm not exactly sure what that is. In my mind, it's kind of a possum, but anyway. Then there's MERS, Middle Eastern Respiratory Syndrome. That's coming out of mostly certain species of camels. So we don't have to worry about that, not having a lot of camels here in Hershey. And then we have this COVID. Everyone before this COVID, people in my field were most worried about another influenza outbreak. If we have an outbreak like similar to 1918, that will be really bad, could even top COVID as far as its severity. But that has not happened yet. So this COVID-19 took a lot of people by surprise. Here's what the virus looks like. We're going to talk a lot today about the spike protein. This is the attachment protein that the virus uses to attach itself to enter our cell. This is a very specific reaction. It has to find its specific receptor on the cell and then enter that way. If the receptor is not there, or if it gets blocked, or if this spike protein gets blocked, as we'll see with neutralizing antibody, no attachment happens, and then we're all good. And this is where, when we're talking about variants, this is the protein that we're focused on, because the variant, we do know there have been mutations, several of them with mutations that say with the UK, this virus is now a lot, that variant, the UK variant, is a lot more contagious than the kind of the wild type we had before. It gets better binding with the spike protein, and there are more spike proteins on the surface, so it's easier for the virus to attach. So we'll get into variants here in a little bit, but that's this is where the action is really happening. Now, fortunately, a lot of my different assays, we have 8 different assays looking for this one virus. Okay, with everything else I look for in my lab, we just have one platform, or maybe there's 2 if it's part of a big multiplex test, but usually 1 is quite enough. And the reason we had to have this many is, at the beginning, I'm sure you've heard, there was a real shortage. No one company could supply or our country's need, let alone the world, as far as the test we need. So every company we were working with, we were on fairly strict allocations for what we would get. So that's why we had to ramp up to 7 different platforms. Some of them are, a couple of them are even kind of brand new and somewhat exotic. We'll talk about that later on. But we had to do that in order to provide the level of testing that the hospital was asking us for. And one more thing, this is a single strand of RNA in here. There's 2 things that makes this virus fairly fragile. Does not survive well in the environment. It's this lipoprotein envelope around here. Can kind of think of that as a bubble, if you will. That does not survive well in the environment. You know, in the beginning, we were all concerned about, oh, you've got to super clean all your surfaces. I was leaving all of my groceries out on the back patio overnight and spraying them down with Clorox solution. Turns out that's really not necessary. This virus spreads by sharing air. And if you would kind of get that 6-foot idea out of your mind, 6 foot, 3 foot, 10 foot, that's kind of the bare minimum that you would want to do if you're around somebody. But kind of think of this, an infected person is producing a cloud of virus. If you're in a room, think of somebody smoking a cigar. 6 foot is not going to keep you out of that smoke. That's the very similar to what this virus, how it spreads. That's why air exchange and ventilation is the most important thing that we can do as far as controlling this spreading indoors. I'm on several committees with the Methodists, and we're trying to decide how to reopen our church, what groups can meet in there, how does the district go back to working in their office, and it all gets down to basically the ventilation and air exchange. Social distancing, of course, is great. That's a bare minimum. But just staying 8 feet away from everybody is not going to be good enough to keep you from getting this if there's an infected person in that room and you're not vaccinated. Okay, so this time of year, this is a list of viruses we test for during the winter. I have one instrument that will test for all of these at one time. It takes a little over an hour to do this. Used to, when we were doing cell culture, it would take 2 weeks to report all of these negatives, and some of them we couldn't even grow. So this has been a huge improvement for us. And around last fall, here's the 4 coronaviruses we're looking at every year. And then this got added to it as well. Pretty much everyone who's admitted to this hospital will have this test run on them. Absolutely, if they have respiratory symptoms, because we'd like to know who the patients are that are infected so they can be placed in isolation. But as of until last week, we had not seen one single influenza case the entire year. That is just unheard of. It's unreal. Last week, we did have 1 case of influenza B. That kind of makes sense. This is the time of year we normally see influenza B. Normally, it's influenza A earlier on in the winter, and then it switches over to B. Respiratory syncytial virus, this is a big problem every year with children. For adults, if you get a cold and you're going to cough for weeks, it's usually due to RSV, and we get those every year. Parainfluenza may think you may think you had the flu, but you're not. And then there are these others down through here as a cause of pink eye. And then community acquired pneumonia can come from any of these 3. These are all extremely rare this year. We have not seen a single metapneumovirus all year, as was the case with the flu and respiratory syncytial virus. Maybe just a half dozen cases there. So the bottom line for that is everything we're doing to mitigate the spread of COVID-19 and the masking and keeping kids at home, staying away from each other, that works very well for the rest of these viruses. And like I just mentioned earlier, apparently it works pretty well on pollen too. There's an extra bonus for that mask. This is what the test looks like. It's extremely simple to run. This is a relatively new technology. but it is so simple. Earlier during the pandemic, the hospital closed down a lot of its clinics. We were almost down to doing half of the work that we were doing normally, except for my lab, and we were doing like triple the amount of work. But what was happening, we had a lot of really good laboratory technicians up and down the hallway here in clinical pathology with not enough to do. So this was simple enough. We were able to cross-train them, and there for a long while until we were able to hire enough people to cover everything. Lord, half the people working in my lab were not my employees, but were coming from micro, from chemistry, some from anatomic path, but they had the skills that was needed to run this test. Okay, so clinical presentation of COVID-19. Transmission is by respiratory droplets. But again, these droplets can dry down, and there have been studies shown that they can stay suspended in the air for up to 13 hours, fully infectious. So again, a lot of the larger droplets will drop within 8 feet, 10 feet, whatever number you happen to be using. But again, a lot of those will stay suspended in the air for a long period of time. Incubation period is 2 to 14 days. This is why if you've been exposed, even without symptoms, you are going to be in isolation for 14 days. That's where that comes from. You may not show symptoms or be shedding virus until, day 14 or day 13 or day 12. So most people are much earlier than that, but that's where that 14 days come from. Asymptomatic infections, 81% will be very mild, maybe even to where you don't even notice it. 14% can be severe, 5% can be critical. These are much worse numbers than what you see with flu. I know in the beginning, a lot of people are thinking, oh, well, this is just another, this will be like the flu. And that is so not true. This is much, much worse than flu, as we'll see with the complications it causes. Fatality rate, somewhere between 2 and 4%. And in infection fatality rate, if you just look at all the infections, that includes the asymptomatics, that's between 0.5 and 1%. That looks like a low number until you're talking about, millions upon millions of people, and that gets to be a high rate. Now this up here, where we talk about severe and critical, there's a lot of people, even mild we've seen, a lot of people who will recover from a severe or critical infection. That means they did not die, but they may never fully recover. There's, of course, you have, I'm sure you've heard of the long haulers that have symptoms that go out a long way. There can be neurologic changes, damage to your lungs, to kidneys that, may or may not ever recover from. So, there's, death is just not the end of this infection. It can go on for a long, long while after that. It's one of the reasons I get so frustrated with people who want masks and be vaccinated. They are, this is a very serious chance they're taking. Okay, as far as symptoms go, fever is by far the most common. The cough would be second. Of course, there's a lot of different things that we could that can cause that. Even we thought about allergies, but like I said, it looks like allergy season is going to be fairly mild this year. We were scared to death at the beginning when this was starting. Oh my God, we get hammered pretty hard every year with influenza. And a bad influenza year, normally we have about 30,000 people a year die in this country. A bad year is 60,000. So, look at, we're almost up to 600,000 now. So again, this is not flu. Fatigue, this can go on. This may be your only symptom. Gee, I'm really tired. And it can go on for a long, long while after recovered. Okay. So complications, you can have respiratory failure. That's what, usually think with these respiratory diseases that are spread. And that's true. But like I say, it's much more wide. Complications are much more varied than that. This virus actually will cause inflammation in the blood vessels. And so as far as, you think of your organs and where you got blood vessels, and that's why it can spread to a lot of different organs. You can have cardiovascular disease, blood clotting, this hypercoagulable state. You know, people are all worked up about the J&J vaccine and this extremely rare complication. It's not even far enough above background that we would normally see without the vaccine to say, you know, in fact, that this is due to that. There's a lot of work going on to see why these, I think there's 6, maybe 7 cases known so far. What is unique about these patients that led them to having that particular complication? You can have cerebral vascular disease, encephalopathy, can affect pregnancies. Yes, pregnant women should definitely be vaccinated for this virus. Not only will it protect them, often pregnancy leads to a little immunosuppression. So if you get the virus, you have a higher chance of complications with it. So yeah, we'll just answer that one right now. Secondary infection is true with a lot of viral respiratory infections. They set you up for a secondary bacterial infection. A number of these deaths have been due to that, either a bacterial or fungal pneumonia. There's Guillain-Barré syndrome, where it's an autoimmune disorder. Again, that's well, it's not uncommon even before COVID-19 came along. And then in pediatrics, and we've seen a few cases now in adults, it's multi-system inflammatory syndrome. It can be very severe. We have seen several cases here at the Med Center. And again, like I say, the virus is causing inflammation within your blood vessels, and that's what's leading to this. Okay, so just a word about the vaccine. The J&J problem, you can see out there the likelihood, 6 cases and almost 7 million doses. If you look at birth control pills, that's between 50 and 1,200 cases in 1 million patients. Cigarettes, higher than that. And then finally, if you get a COVID-19 infection, that's 165,000 cases in 1 million infections. So if I were not already vaccinated, and I was offered the Johnson & Johnson vaccine, would I take it? Absolutely, because you know, look at the difference between my chances of the similar symptoms or complications with COVID infection versus J&J vaccine. I do think that they pulled that from just a huge abundance of caution. And fortunately, we have the other 2 vaccines. We're going to talk in the function of these vaccines here in a minute. To carry us through. We didn't have to shut down our vaccination program. But I just kind of wanted to put that into perspective for you. You'll hear all kinds of stuff on the internet, the web. Anti-vaxxers, of course, are having a field day with this. Oh, we told you so. But, you know, look, it's 6 cases out of 7 million doses. Okay, so we hear a lot about high-risk individuals. If you notice severe obesity, that's number 1 on the list. It's also number 4 on the list, except it's just obesity, not severe obesity. So yeah, overweight people are very high risk. Chronic kidney disease, if your kidneys are already struggling and then they get hit with inflammation from this virus, well, that doesn't go well. Diabetes is also known to be high risk. And then the other ones drop off very rapidly after that. So if you look at the first 4 or 5 there, those are high risk people. And of course, that doesn't even include immunosuppressed patients. But you look at that list and you look at Americans, 41% of us have at least one medical condition that puts them at high risk for severe COVID-19. That's one of the reasons we're approaching 600,000 deaths from this in just a little over a year, which is just a staggering number. But when you look at all those conditions on there and you think of how common they are in our population, it's not hard to see how we got to that death toll once people were actually infected. Okay, so how to prevent it? Hand washing, that's always a good idea. Covering your cough, again, I don't like this picture. You should never cover your cough with your hand. it should go into your sleeve. If you cough in your hand and you touch a doorknob or whatever, well, you might as well have used your neighbor's hand to cough into instead of your own, because it can spread very easily that way and survive for hours on a hand. Touching your eyes, nose, and mouth. That's another good reason that these masks will work. It keeps your hands out of your mouth. And there for a long while, I wore these goggles everywhere. They would not keep the virus, in the air or out of my eyes, but they kept my fingers out of my eyes. They did a really good job with that. So when everybody was just super, super concerned with the spread of this, we didn't really understand it well. Leaving our groceries out in the patio overnight, that seemed to work pretty well, but it's not as important as we once thought. Cleaning, I know our church is, when we go back, they were all these super elaborate protocols for wiping down everything and letting it so much time in between services or activities. That's not a bad idea, but that's not where the big bang for the buck is coming from. That will be on, again, like I said earlier, ventilation and air exchange. I'm one of the main reasons I like going to church is I'm a hugger. That's you can't do that very effectively over Zoom, but we have had great services, so that part is working well. But it's been a long while since I have been shaking hands. Elbow bumps are the thing. Okay, and we've already been over the symptoms. So here's a little bit of the science. Okay, we have two vaccines, the Moderna and the Pfizer, and you've heard that they are messenger RNA that have been packaged, and that's what's in the vaccine. This is the first time this has been used for a human vaccine. I'm very excited about it. It's a very elegant concept, and we were able to develop these millions upon millions of doses because of this technique. If we were having to produce vaccines the way we do for our flu vaccines now and grow them in the virus in fertilized eggs, we wouldn't be anywhere close to where we are now. So it's actually my hope that within a very short period of time, a year or 2 years, our flu vaccine will be made this way too. It's these messenger strands of messenger RNA that can be produced very easily in a lab in enormous quantities. If there's a mutation, that every now and then with our flu vaccine, usually if there's a bad flu year, it's because there was a mutation when that virus is placed into chicken eggs. It mutated to grow better in chickens than humans. And it was nowhere near as efficacious as it would have been if it had not mutated. So by using just the information itself, the messenger RNA, it's be relatively easy to produce new or update our vaccines. That's already going underway with the Pfizer and the Moderna vaccines, because we'll mention the variants here in a little bit. South American and Brazil variants are they're a little nasty as far as some of our treatments, and maybe our vaccines a bit less effective against preventing infection with them. Our vaccines are still with those two variants, essentially 100% protective from severe disease and or death. But as far as becoming just ill with some symptoms, not quite as good. So I do know that there's boosters working on with those two vaccines. And again, it's just tweaking the messenger RNA. It's done in a lab. You don't have to grow it in anything. So anyway, so the way it works now, the virus attaches with its spike proteins to this ACE2 receptor that we have on a lot of our cells. It's a normal part of our makeup. It will fuse. It releases the genome. This is replicated the main instructions for the virus into messenger RNA. Now, this messenger RNA, it's fairly fragile. Our body, that's how we make proteins. We're full of messenger RNA, and it's not meant to survive in our cells for a very long period of time. It breaks down relatively quickly. That's why our body can respond to different needs is, well, if we need more of that particular protein, well, it'll make more messenger RNA. If we don't need that protein, well, then it won't, and then there'll be no messenger RNA to make it, and it goes away. So this messenger RNA happens. It will make the proteins, it gets reassembled, and then goes out into a new virus. Now, the J&J vaccine, this is different. Remember I told you that the SARS-CoV-2, it's a single strand of RNA. And those viruses, all of them, are notorious for mutating. DNA, even DNA viruses, there's kind of a little proofreading that goes on. So when it makes a copy of itself, if there's a mismatch nucleotide put in, it'll cut it out and put in the correct one. So RNA viruses don't do that. But if you're making trillions of copies of yourself, if you make a copy that doesn't work, it doesn't really matter. There's plenty of others. Now this double-stranded DNA, it's fairly stable. That's why, you know, there's been sequencing done in mummies, and you can have crime scene investigations looking for DNA, because in the environment, that double coiled helix here, that's a fairly stable structure. So that's the big difference with, well, the next slide will show it better. So the J&J vaccine, they have taken an adenovirus that has been modified to where it's totally non-infectious. It cannot replicate at all. You know, after getting the vaccine, if I tried to find this virus in you, I couldn't, because it's been modified to where it cannot grow. But it does contain the genetic information, the DNA here, for making the spike protein. So when it gets down into your cell, the DNA gets released, and from there, messenger RNA is produced, just like happens with all of our proteins in our cells. It goes to the ribosome, it makes the protein, and that is released from the cell. Our antigen processing cells will see this foreign protein and trigger an immune response. So that's what's going on over here. Whether or not you can get kind of a modified immune response due to the presence of this adenovirus, people are looking at that. Adenoviruses are very common. We find them causing respiratory diseases all the time. There's your pink eye, and there are a number of adenoviruses that infect us that don't do anything. So that's one of the reasons this was chosen as the package, if you will, to deliver the DNA, is because it's fairly stable. But there's looking to see if this particular structure has anything to do with some of these side effects. That's certainly not known, has not been shown yet, but that's one of the things folks are looking at. Now, over here with our messenger RNA vaccines, they have been placed in this little capsule. There's a number of different compounds that make this thing up, polyethylene glycol being one of them. But it's a fairly stable structure. But, you know, you've heard that the J&J, you can keep that in the fridge for weeks, and that's just fine. These over here, when the Moderna first came out, it had to be stored at -70 degrees centigrade, which is kind of a problem because a lot of labs, certainly most physician clinics, will not have a -70 degrees centigrade. My diagnostic lab does, but we do a lot of other work too. So this -70 was kind of a big problem. Now they've found out that, yeah, it is stable at -20. So that allows it to go out to a lot more vaccination sites than if it had stayed at -70. And then, like I say, over here with the J&J, this can just be kept on ice packs, kept in a fridge. So as far as particularly getting it into developing countries, poorer areas, this has a huge advantage as far as being able to ship it safely. Okay, so I hope that that gives everybody a clear understanding of these different vaccines. This is a single strand of messenger RNA. You know, I have heard of people, they're afraid of the vaccine because it's going to change their genetic material. Now there'll be a genetically modified organism. And that cannot happen with either of these. This cannot become part of your genome. This is a fragile little molecule that's going to break down quickly. It certainly won't replicate along with your cells. Neither of these will. So there's no genetic modification of our material moving forward with these. They're kind of a once and done vaccines. And so when they say have done their thing and the immune response comes along, this is kind of where we were earlier, but you can see what happens with these neutralizing antibodies. They are specific for these spike proteins. And so they'll just coat them. And if they're coated with these big bulky antibodies, they can't attach to the host receptor over here. And so that's how the protection, our protection comes about. So now we come down to questions. I have a few that I'll go over that I've been asked over in the past, and then we'll open it up for you all. Okay, so how does it spread? We touched on this earlier, mostly through the respiratory tract, not so much by touching. It's still a good idea to wipe down surfaces, don't pass the collection plates, all that business, but again, that's not the major way. It's through sharing air. Okay, we talked about how the virus can stay suspended in the air for hours. Okay, so what happens if you should become ill with the virus? You isolate for 10 days, beginning with the start of symptoms, and that will go on until you have no fever, 10 days or no fever. That's how long we have found that if you take someone who's infected with the virus, they're ill, and you go looking for the virus, infectious virus, and this is kind of a hard thing to do, it requires cell culture. You're not able to grow the virus back out of a person usually after 10 days. Now, immunosuppressed patients, yeah, we found virus in them for weeks. Or for other people, we can find the evidence of the virus's genome for weeks, but they're not infectious. The body is just kind of shedding inactive virus from when the infection was alive and working. So the best things to do: rest, stay well hydrated, treat the fever if needed, and then if the symptoms become worse, of course, get help quickly. And then quarantine yourself from close contacts for up to 14 days. Again, it takes that long to be sure that you're not infectious. Okay, so lungs. There we know that there can be very prolonged damage, maybe permanent damage from the lungs. There can be damage directly by the virus growing in those cells, leading to scarring. We mentioned the secondary infections with bacteria. You've heard of double pneumonia. That's a common term. Well, that's where this is coming from. You can get an overactive immune response. That's where a lot of this pathology is coming from. And of course, blood clots. Again, all these can lead to scarring. It can be very slow to heal. And again, we know that a lot of patients who have severe reactions to this infection is due to an overactive immune response that can damage not only the lungs, but other organs as well. Okay, can you be infected from an asymptomatic person? Absolutely. That's why we're in such a mess with this pandemic, is that asymptomatic people can be enormously infectious. A lot of our tests, I can measure the amount of virus that's in that sample. And there's a term that we're measuring, is called a CT value. And these, some of these patients are astronomical, much higher than we've seen with flu and RSV and these other viruses. And feel perfectly fine. There was one case, it was a young fella who's out riding his dirt bike, broke his leg. Okay, he's going to have surgery, gets tested, and he had an enormous amount of virus he was shedding. Yet he felt perfectly fine, and he was out dirt biking until he crashed his bike. So asymptomatic people are what's the main reason that's driving this this pandemic. Of course, if a patient is sneezing or coughing or has a fever, well, it's a little easier to recognize them, to isolate them, and to avoid them. Also, I've always had on my list people you want to avoid. And these are real easy to recognize. If you see somebody coming at you without their mask on or their nose hanging out, these are people to be avoided too. When I was doing the shopping, I always wore an N95 mask into those settings. And if I saw somebody in the aisle, I would just avoid that aisle for a while, because if they were infected, they could have left, quite a cloud there. Okay, so some questions that Tim had mentioned earlier that I received from you all is, how's the time course and pattern of spread compared to prior pandemics? We touched on that, I think, with the 2009. I was feeling pretty good after that 2009 pandemic. The rule of thumb is we have a pandemic about every 30 years. That was 2009. I plan on retiring next year. So I thought, okay, I'm through with pandemics. Did not see this particular one coming on. So 2009 was a more explosive spread, but this has been for a much more widespread and lingering pandemic just because of these asymptomatic infections. How it's passed from animals to humans, still not a whole lot. It's still thought the most, I say the top theory then of where did this come from? It was from interacting with bats in China. Pandemics, usually flu pandemics come from interacting with either most commonly with pigs, or on occasionally with birds, poultry. But zoonotic viruses, I don't know, if you're going to have to get people to stop eating things that most of us would never dream of. And that's kind of a cultural thing. And I don't know what you can do about that. Even if you say no more live markets, and China has shut those down numerous times, there's still plenty of a very active black market for those little animals. We talked earlier about public health infrastructure to respond to emerging pandemics. We have talked about this for years. Certainly, there was a lot of talk and a little action that went on after the 2009 swine flu, but nowhere near what it needed to be. Now, I think we are in much, much better shape. A lot of laboratories have greatly increased their ability to test. And one thing, there are a lot of new techniques, a lot of new companies. They have a lot more capacity to produce assays. So we are in much, much better shape than we were a year ago as far as being able to come up with diagnostic tests. So that's been a plus. Also with the vaccine technology, we mentioned that earlier. If a lot of our vaccines can get switched over to this messenger RNA, then development will be a lot quicker, a lot cheaper. If we need to make, modify the vaccines in any way, that can be done in a matter of just a couple of months instead of maybe a year's time change. So tremendous improvement in our vaccine technology. Feel good about that. How did social media help or hinder the response to this pandemic? Boy, you talk about a double-edged sword. This is a classic. And just after I read this question, Penn State published a study, and they came up with a list of questions. They made up a test, and they gave this test to 3 groups of people: those who identify themselves as getting their information mainly off the news, either the internet or the TV, that's their main source of information. Then another group that mainly got their information off of Facebook and those type of platforms. And then those people who would go to the CDC's website, the WHO, the NIH, Penn State's website, our Department of Health, respected, fully vetted sources of information. And you can probably guess how the test scores fell out with those getting all their information off of Facebook, scoring the worst. It's no secret that anybody can say anything without any backup whatsoever on the these social media sites, and can look very good. The anti-vaxxers have had just a heyday with this. And, you know, I'll get a lot of my friends who'll say, well, I just saw this. What do you think? Here's what this doctor said. And, you know, it takes maybe a half an hour to pick through everything that a lot of what that doctor said is just not true. But if you don't have the background or actually do the go into the references, and usually there's not any, there's a tremendous amount of misinformation. And that's why we're having a lot of trouble with people not getting their vaccine, is they've got a lot of bad information. Emerging technologies, response, of course, we have diagnostic tests. Used to be, you hear a lot with these variants about sequencing. That was up until just recently very much performed in research labs. It was not a diagnostic test. It's fairly slow. Of course, it's getting faster now because you have a lot of improvements, relatively expensive, but that's coming down too. But it was just not ready for prime time in a diagnostic lab. However, there have been a lot of changes, new tests coming along, new platforms, and a lot of my colleagues are using sequencing to look for this virus. We do here, but it's over in one of our research labs. We test, I'll send over about 15 or so random samples a week, and they will do a full sequencing. And what we are finding here with that method, and then I'll explain what I'm doing in my lab, well over a half of the isolates that we're seeing are the UK variant. And I remember earlier, the first week we received one of these, it was kind of exciting. It's, oh, you know, well, it would be exciting to a virologist, not many other people. But we did find, you know, a single isolate of the UK, and it's okay. It is now moved into our area. And within 2 weeks, that was the predominant strain. That virus is so much more infectious than what we had previous. It was easy for it to crowd out everything else that was essentially other things as well. There are also variants. There's one that's fairly infectious up in New York, and that is down in our area as well. That's probably our second, well, it is our second most common variant that we see here, UK first, and then that. And then you've heard about the South American and the Brazil. They're not, apparently, we have seen 1 or 2 cases in our area, but even in the entire country, we're not seeing that those 2 viruses are not establishing themselves over what's being seen with the UK. And of course, in California, they have 2 variants over there. East Coast, we're dealing with the New York variant. What's good about the UK and the New York, though, is the vaccine is still fully protective. So if you're vaccinated, you're all good. If you're not vaccinated, you've got a much higher chance of becoming infected. So that's how that works. And we mentioned the vaccine technology. I have very high hopes moving forward with a lot of our current vaccines. I'd love to see them switch over to this messenger RNA. It's much faster, much cheaper to produce, and it has a lot less issues, particularly if you're having to grow the virus and then either modify it or inactivate it. So those are, that's pretty much what I have. I will stop sharing screen here, maybe, and I'll take other questions.
Great, thank you. I just wanted to reiterate one of the points that you made was regarding the kind of the longer lingering symptoms that we're seeing with this virus. And certainly we're seeing that in radiology when we look at the pulmonary effects of this virus, the marked amount of inflammatory fibrosis that occurs. So, you know, patients with relatively mild symptoms getting pretty significant interstitial lung disease. My concerns are we're going to be treating this pandemic long after we clear the virus from the community because of these longer term impacts. It's certainly a lot different than what we see with other viruses, as you mentioned. We did have a question from Sally McKinney, and she was wondering if you could talk a little bit about some of the treatments that we're using for COVID-19, particularly about monoclonal antibodies.
Okay.
That was an early treatment early on, not using it quite as much now. Maybe you could talk a little bit about the treatments that are available.
Right. Well, we're still looking for better treatments. I think we're up on our fourth treatment study here, helping out with the FDA on these different studies. There is an antiviral that seems to help a bit, Desivir, but it's no magic bullet. It's not like the antivirals we have for flu. It may help a little, but not greatly. Now, with the monoclonal antibodies, again, that's we're trying to make antibodies that will coat the spike protein, like we saw, we're doing with the vaccines. But rather than having to depend upon your body to produce those, they can be produced in the lab. It's hard to make these in quantity. This is not an easy thing or an inexpensive thing to do. And they're finding out for these to work, you kind of need to have a cocktail of these, looking for different targets on that spike protein. And that's one of the big problems with the South African and the Brazil strains, is they have mutated enough that these monoclonal antibodies, as far as treatment goes, are not working that well. Now there's a study, another drug that's going on. Oh, and these are all given IV as well. I do know there's a lot of study on a new drug. I forget its name, but it's an oral drug. So you would not have to be admitted for an IV. It could be taken over the counter. And it seems to be helping to reduce symptoms. But again, I don't even think it's in official clinical trials yet. It's still in development. But there's not a lot going on. Treatment is not going to get us out of this pandemic.
The other thing we find with antibodies too is you generally have to administer them fairly early in the course of the infection. As you mentioned, this long prodromal phase where patients are not demonstrating symptoms, and then it's about day 8 or 9 that they become more severely symptomatic, doesn't leave you a large window to administer those.
Right. Once the damage is done, it takes the body a long time to heal sometimes.
Well, one of the other things that we're seeing is a lot more use of forecasting for viruses. I'm thinking about things like the IHME website. There's a lot of forecasting models out there. People started looking at the potential role of doing wastewater testing to try to identify when the virus is coming into the community. How is, and there's technologies like the Kinza app, which is a thermometer that takes temperatures from various zip codes and then correlates that with testing prevalence. That has shown some ability to be able to predict when we might start to see surges in viruses. Can you talk a little bit about our ability to kind of forecast the community spread of these viruses, and if you think that'll be a useful technology in the future?
Well, the CDC has actually been doing that for years with influenza. They will monitor even the over-the-counter buying a CVS, Rite Aid, whatever, or drugstores of flu remedies or cold remedies, and they have make some very elegant graphs to show that if that's going on, that's can be a very good marker of an outbreak going on in places. I know that up at Penn State they have been looking at monitoring the wastewater coming out of sewage plants. There's a tremendous amount of this virus that is spread in feces. And they are able to detect it. It amazes to me, considering how fragile this virus is and the RNA. But yeah, they have been using molecular techniques to detect it there as well, to see if there's a higher prevalence. To me, you should your clinicians should be able to tell you if there's a higher prevalence or not, just from the number of people that they're seeing. But yeah, you can detect an outbreak of this virus looking at wastewater. That is true.
Let's see if there's any other questions that are out there. We're getting kind of near the top of the hour.
I have a quick question.
Yeah.
Once somebody has had the COVID and is released from quarantine, if they lost their sense of taste, how long might that take to come back?
That's a whole long range. I have some friends, that to me, I love to cook and I love to eat. That would be devastating to me. But that's a range. Again, your nerves have been affected. That that happens in a lot of different ways in different people. I'm glad you brought that up. That caused another little nerve to fire here. If people who get asked this a good bit, if I've had COVID, do I need to get vaccinated? Absolutely. We know that the immune response is much stronger with any of these three vaccines. It can be from a natural infection. And also, I just read this week that this was kind of exciting to me. When they looked at our patients' lymph nodes that have received these vaccines, they saw structures called germinal centers. And those are areas where your body is really ramping up, it's taking your immunity up to the next level. And these will give you a much longer lived immunity. And the fact that they were finding these with these vaccines, that gives me hope that these vaccines will last much longer. Right now, I think Pfizer is saying theirs is good for up to 6 months. They're saying 6 months because that's all the data they have. In another 6 months, they may be able to say, well, it's good for a year. We don't know. Will we have to get yearly boosters because of mutations? That's very likely. But again, I'm glad you brought that up. But absolutely, if you've had this before, you certainly still need to be vaccinated to have a long-lived immunity. And we also know that the better your immune response, the more likely you are to be able to weather one of these variants. If you have kind of a so-so immunity and you get a variant, say one of those from South Africa, Brazil, you may have more problems than you would if you had been vaccinated.
Ms. Walt, I think we have time for one last question. And Debbie Hook has had questions. And I'll just kind of rephrase it. If you had one thing that you could change to make us more prepared for an upcoming pandemic, what would it be?
Well, what hurt us the most in the beginning? Well, there are two. I'm going to cheat and give you two.
Okay.
After the flu pandemic, we did have a big stockpile spread all across the country of personal protective equipment, N95 masks, gowns, gloves to protect healthcare workers, first responders, all of that. And that was allowed to deteriorate. We need to keep that, if anything, enhance it. Now, as far as one thing that has happened, and I don't see this ever changing back to the way it was beforehand, is our surveillance is much stronger than it was. Our departments of health, to be able to do screening and then contact tracing, we've been forced to really ramp up. And as far as, people who run diagnostic labs, where I may have had maybe 4 or 5 choices for good assays, now I have a dozen or more. And even like we are using mass spectroscopy, that's a whole hour lecture there. But if you told me a year ago I would be using that in my virology lab, I'd say, no, there's absolutely no place for that. But that's how we're looking for variants. Right. It's very simple, very elegant, but and a lot of labs have done this. So we are much better prepared as far as that goes. And again, I have super high hopes with a lot more people are doing sequencing. So that's how we find new things really fast. And then our vaccines.
Well, thank you very much, Walt. A lot of information, a huge topic to discuss. I think we learned a lot from having you join us today. Really appreciate the time that you gave to better inform us this morning. And hopefully we'll all be better prepared for the future pandemic.
Well, thank you, Tim. And feel free to share my web address with anybody, my email address. And I just ask you, don't start out one with saying, well, I heard this on the Facebook. I've kind of stopped responding to some of those. It just gets my blood pressure up. So,
well, probably the biggest thing we need is good information, and appreciate you providing it this morning.
Well,
all right.
All right. Thank you.
Thank you, everyone.
Enjoy this beautiful day.
Absolutely.
Thank you very much.
My pleasure.